Hi friends, welcome to my channel. In today's class, let us discuss how to do the projections of a given plane, that is isosceles triangle. Here isosceles triangle means, so I am taking this is isosceles triangle. It has two sides equal length. Okay, this length and this length has same value compared to the third side. Okay, so this triangle is called isosceles triangle, and we are calling this is a plane because it has no thickness. If you see the thickness, it is looking like a line. Okay, so negligible thickness, it has only two dimensions, it has width and it has height. So whatever two-dimensional objects are there, we can call it as plane or plate. Okay, here we are taking the shape of isosceles triangle. Okay, let us take the given data. A plane having shape of isosceles triangle has base 40 mm. So this base is 40 mm and altitude is 54 mm. Altitude means height of the triangle is 5.4 centimeters. Okay, it is so placed that in the front view it is seen as equilateral triangle. We are keeping this isosceles triangle in such a way that it is looking like equilateral triangle. Equilateral triangle means all three sides has equal length. Okay, so this side and this side has same length. We can call this triangle is equilateral triangle. Okay, so this triangle is looking like this. Okay, we are keeping like that. Equilateral triangle of 4 centimeters, 40 mm. All three sides has 4 centimeter. Okay. Having a side inclined at 45 degrees to the reference line. Okay, and this equilateral triangle is, one of the side is making 45 degrees to the reference line. Okay, which side it is making? 40 mm side. Draw its top view. Okay, we need to do the top view. Here front views are given. So it is given in the front view, it is seen as equilateral triangle. So front view is given, we need to do the top view for this given triangle. For assuming the position of it, let us take the given plane in the 3D view. We are taking all the planes in the first quadrant. We keep the first quadrant like vertical plane and horizontal plane. Okay, so this is the first quadrant. This is a vertical plane, this is a horizontal plane, and the line joining both planes is XY line or reference line, and the angle between this plane and this plane is 90 degrees. It is called first quadrant. Okay, so in this first quadrant, it is the 3D view. We have to take the triangle, which shape it is? Isosceles triangle. So this is the isosceles triangle. Okay, and it has base 40 mm. This is 40 mm, and the height is 54 mm, like this. This height is. So it is in the front view. It has given. Okay, it may be like this, or it may be like this, like that. Whatever above XY line is coming, it is called front view. Below XY line, it is called top view. Because if you are taking the position of the triangle like this, if you see from front, whatever view it is getting, we are calling it is a front view. If you see from top view is coming on the, either on the XY line or in the HV. Okay, below XY line it is a top view. Here if you want you can write top view will get in horizontal plane and front view will get in vertical plane. Now after getting front view and top view, we are tilting this horizontal plane in downward direction so that both views we can see in the same plane. So this projection is called orthographic projection, two-dimensional projection. Okay, so two views are coming on the same plane. It is a 2D view or orthographic view. Okay, here take an isosceles triangle has base 40 mm and altitude 50 mm. It is so placed that in front view it is looking like equilateral triangle. This isosceles triangle is looking in the front view like equilateral triangle. So it is looking like equilateral triangle. How it is looking like equilateral triangle? If you are keeping like this, in the front view it is looking like isosceles triangle, not equilateral triangle. So if we are tilting like this, okay, at some angle with the vertical plane, it may be looking like equilateral triangle like this. Okay, any triangle or any polygon, if it is tilting, it is looking like reduced polygon or reduced triangle. Okay, here he has given in front view it is looking like equilateral triangle, means this plane is making some angle with the vertical plane. Got it? So at the time the front view is looking like equilateral triangle. Of what side it is? 40 mm each side of equilateral triangle. All sides has 4 centimeter. Okay, the meaning is initially it is like this. Again it is tilting some angle. Okay, so take the initial position. Initially assume the position like this. After that we will take this angle. Okay, so initial position I am assuming. Here this gap is not given. We can take any gap here. Just do the front view. Always remember in front view he is talking. He has given front view is equilateral triangle, means the plane is also in the front view. Now take, initially the plane is in the VP. So in the front view we can see the same as it is isosceles triangle of the, this base is 40 mm and altitude is, height is 54 mm. Okay, this height is 54 roughly I am making here. So it is looking like isosceles triangle in the front view. First assumption. After this assumption, what he has given, it is so placed that in front view it is seen as an equilateral triangle of side 40 mm. In the front view again it is looking like equilateral triangle of 4 centimeters. What I am taking? I am taking the projections of it. It is looking like 4 centimeter, already 4 here, 40 mm. So here I did the equilateral triangle. Here it is the isosceles triangle. So in equilateral triangle, all three sides has equal length of 4 centimeters each side. Okay, he has given the same thing here. Okay, he has given this front view here in the question. It is looking like equilateral triangle 4 centimeter. Okay, again what he has given, this equilateral triangle of 4 centimeter having a side inclined at 45 degrees to the reference line. Okay, so this one of the side of the equilateral triangle is making 45 degrees to the reference line. So I am taking this side initially. This side of equilateral triangle is making 45 degrees with the reference line. Reference line means XY line. With XY line, I just take roughly here 45 degrees line. This side is making 45 degrees. Okay, mark this side here and build whatever triangle is there in this direction. We can take in this direction or in this direction. It is our wish. One of the side of the equilateral triangle is making 45 degrees. Same triangle I am taking on the 45 degrees line. Okay, draw its top view. We need to do the top view of it. Initially take for this how the top view is coming. If you are taking in the 3D, the triangle is like this. In the top view, we can see the line. Okay, all planes are looking like line in the top view. Okay, how much height it is, whatever height has given 54, we can see the line here. Okay, it is the top view in this position. Now here, if it is tilting like this means it is looking like equilateral triangle. In the top view, whatever length of this line is there, it is making some angle with the VP. Okay, so here I will do the projector lines like this of some length. Okay, take the initial position. Both points are coming at the same. Here what I am taking, well, how much length it is, actually 54. I am taking this 54 here because we can see the entire length here. Okay, I will mark here this length 54. Okay, so this is the top view. It is looking like an inclined line. This plane is looking like inclined line. We can measure this angle. We can find how much angle this plane is making with the vertical plane. We can find by using the protractor. Okay, this is the next assumption. In the final assumption, we need to find the final top view. For doing the final top view, first we do this diagram in the sheet. Do the XY line of any length on the sheet. Read the XY line of some length. After that, here build this triangle. Okay, here gap has not given. You can take any gap. After some gap, take 4 centimeter line. So this line and this XY line should be 90 degrees. For keeping 90 degrees, here as we know, for this protractor, this is 90. Okay, so take 40 here, 4 centimeter like this. Okay, mark the middle point also. Here take the reference line. At the middle point, mark the height of the triangle, isosceles triangle. The height is 5.4 centimeter. So take this is the reference. By using ruler scale I am doing. Here take height is 5.4 centimeter. So this height will come here. Just mark one point. Okay, join this point to this point and this point. Here we got the isosceles triangle. Give the names for the front view. For front views we are giving A dash, B dash, C dash. So according to the dimensions, base is 4 centimeter and altitude, that is height, is 5.4 centimeter. This is the front view. After that, do the top view. As I told, it is looking like a line. For doing it, we have to do the projector lines at all the points. Do the projection lines at all the points. Now A and B should come at the same place. I am using small a, small b for top view. Here this is small c. Make it dark. Okay. Here after that, after this triangle, take some gap here, any gap. Build equilateral triangle of 4 centimeter. So here I am taking, this is the reference line. I am doing the projector lines initially from A and B. Because AB is 4 centimeter. Okay, I am taking 4 centimeter in this gap only. Okay, and do here also one projector line. Okay, and take this is the vertical line, reference line. And after some gap, after this triangle, take some gap. Take 4 centimeter line. Okay, already it is 4. Okay, we need to do the equilateral triangle of 4 centimeter. The remaining two sides are also 4 centimeter. By using compass, take 4 centimeter. Okay, 4. Take this as a center. Do an arc here. From this also, we will get the intersection point here, same point. Okay, join this point to this one. And this point to this point. So this is the equilateral triangle. So after that, mark the points. So here A dash, B dash I am giving. Here I am giving A1 dash, B1 dash, C1 dash. So in the top view, it is looking like inclined line of this length. Okay, this is 54 mm. Okay, this is also 54 mm. But it is inclined at some angle. Okay, first do the projectile lines. Do the reference line here of some up to XY here. Here, do up to some length. Okay, doing the projectile lines. Take this length. And here mark this point as the center. Okay, now take this point is A1 comma B1. Okay, both are coming at the same point. Okay, this point is the C1. Join A1 B1 to the C1. You will get the inclined plane. Okay, just do this angle by using the protractor. So this angle is showing 50 degrees. So mark here 50 degrees. When the plane is making 50 degrees, this triangle, isosceles triangle, is looking like equilateral triangle. Okay, got it? Again, next he has given a side inclined at 45 degrees to the reference line. Whatever 40 mm side is there, in both cases, which is a 40 mm? This side, and this side 4 centimeter. This side is making 45 degrees angle with the reference line. Okay, so we need to take this line on the 45 degrees line. First take 45 degrees line. Just take any point here. At this point, mark 45 degrees. We can take this side or this side. It is our wish. So here I am getting one point. So join this point to this point for taking the 45 degrees line. Just do one line here. This line is 45 degrees. Now take any one of the point on it. So this side we have to take on this 45 degrees. At some gap, take any point here. This is, I am taking B2 dash. Here I am giving B, B1 dash, B2 dash. Okay. Take this 4 centimeter. So B as center, mark the A point. This is A2 dash. After marking these 2 points on the 45 degrees line, mark the C point also. As we know, this length and this length is equal to this length. Okay. By using the compass, take this 4 centimeter. Just we can build this side or this side. It is our wish. Take this arc here and take here intersection point. Extend this arc, this side arc. We will get the C2 dash point. Join these 2 points with C. So we took the entire equilateral triangle here. It is making 45 degrees. Keep arrows here. So this is the final front view. For getting the final top view, just do the projectile lines at all the points. Take any one of the line as the reference line. Just do the projectile line up to some distance. And from these points also do the projectile lines. So on XY line, we are getting A and B. Just do the line here. And here also do one line. Now take the intersection points. A vertical line, A horizontal line. Take this is A2. Next B vertical line, B horizontal line. Take this is B2. C vertical line, C horizontal line. Take this is C2. Now join all these points. A2, B2, C2 is the final top view. So this is the final front view. This is the final top view. So here in the question they have given draw its top view. This is the final top view. In all the 3 cases, both front view and top view should be in dark color. In the sheets you use pencils, not use pens or sketch pens. Just for showing the clear views I am using the pen and sketch pens. Here mark the given dimensions. For isosceles triangle, base is 40 mm and altitude is 54. Here we have to find the angle, how much angle the plane is making. Here the end, this side is making 45 degrees. So this angle has given here, mark that angle also. Okay, this is a method of doing the projections of the given isosceles triangle. If you like this lecture, please press the like button and subscribe my channel and share with your friends so that it may be useful for them also. Thank you for watching.